Welcome to a new test and teardown video. This time it's an RLC Universal Messbrücke type E316 from a Polish company called MeraTronic. It should be from about 1974, and it contains an oscillator of 1 kilohertz, or I think that will be mains frequency. You select for the mesh frequency. Maybe this is external frequency. We got some connectors in the back. Maybe this is the drive level. And I bet you adjust. See, this is on off, and then you can adjust the read out sensitivity or something like that. And then the idea is we can select all the different ranges and resistor, inductor, capacitor, and all that kind of stuff. Maybe that is some zeroing or some impedance only mode. I look a little bit forward to figure out what is what really. Here it says you need to adjust for 5 picofarads, so that is also a thing. And yeah, we got a little bit of sticky switches. Of course they work now when I want to demonstrate this, but just before I click them a little bit, then they didn't really work that well. How funny is that? This is a typical demo effect thing. This one is should be like a geared. See, but it loses connection, so there's something here I need to clean. Originally, it was supposed to run on this kind of weird special power connector. Also says MeraTronic. That is interesting. So this is definitely some sort of a modification somebody did. It can run on batteries or mains, and you just pull like this to access the battery tray, and then you put in your little batteries like that. We got some internal or external readout meter maybe, and that will be the oscillator, internal or external oscillator. See, made in Poland. And what is that? 1985, maybe. That is the year, right? Or this is a revision or something like that. Because I found a schematic online from 1974, so maybe they made this model here over quite a lot of years. So let's try and open and inspect. How are we going? Yep, we got some screws, so that is going to be quite easy. I just took the side panel off here. The first little thing I was afraid of, I was actually right. See, here's the mains connector, and this wire here was just soldered directly to the back of that mains connector. So that means when you plug this in, it is now dangerous to touch those pins. And it's quite easy to stick your fingers in here. Why would you do it like that and not add some tape over it or a label, or actually just don't do it like this? This is a bad idea and very, very dangerous. This is actually a Philips side panel, isn't it? Yeah, that's exactly where we've seen those before. So they either stole the design or is using exactly the same design. That is interesting. Also, this piece of aluminium and the way this is made, look at that. This is exactly the same as Philips. Also the way where you need to, can you see those little here? You need to be behind those for this to work. This is exactly the same problem with Philips. Definitely. Wow, there's actually a lot more good stuff in this one. I did not expect that. Very big and beautiful potentiometer here. And this gearing here that is definitely not working good. Maybe there's a way to get into that area. I don't know yet. So we got a lot of resistors and stuff down there. What else can we find here? A little extra circuit board down there. That will be the different modes. Is that okay? That's just a capacitor. Well, I think I'll take away all the side panels and then inspect a lot more. I'm looking for leaked capacitors or burned components or anything that prevents me from powering this up, or at least just delays me a little bit. So here's the bottom view. We can better see the transformer and the power supply board. I believe this power supply board is also the rectifier and oscillator. That big inductor right there, and only one transistor as far as I can see. That is just the oscillator, and there's only a few more diodes and not a lot of extra things down there. What else can we say? We cannot see any more cool things really. Just all those connectors, the little trimmer there, and here on the little amplifier board, that will just be for the meters, and only two transistors, or no, there's one more down there, right? See, we got the two silver ones, and here we go. There's number 3. Just 3 transistors. I should definitely find the schematic for this one. And that big silver part in there in the middle is probably a relay. Yes, it is a relay. Well, I think I want to power this up and see what happens. What is the worst that can happen? Not a lot of dangerous stuff here, right? So let's try and see what happens. .7 watts. Oi. So we got a readout here. What have I done here? We are in resistor mode, and I put this for 1 kilo, and I put in two 1 kilo resistors, and then I would expect I don't know exactly what to expect, because this is, what is this? I should find a peak, right? But I am in the middle. Maybe I should put in 5 kilo. Maybe that is what I should do. See, this is 4.7 K, and I am in 1 K. So I think this is the scale, and I think that yes, see, the meter goes low, and then I think you give it more amplification, and then yeah, that is how it works. And then you can crank up the amplification, and then you will get a much more accurate bridge reading. Look at that. And I bet that is 4.7567 and a little bit more than that. Maybe the resistor is a little bit high. So at the first point it seems to be working, but that is giga ohms. That is interesting. So if this is really true, that means I finally got something that can measure many giga ohms. I want to try that. I don't understand the scaling. There's something wrong here. So if it would have been the same kind of thing, I mean, in 1 kilo scale, I have 4.7 here, right? So, I mean, those are the numbers I add to that one, right? But if I go to 1 giga ohm, see, it's the other way. Then it's up here, and this is 1 giga ohm resistor. Why is it not the same? That does not work. Damn it. Now this is 4.7 mega ohm, and we are here. Ooh, it is sensitive. And again, the negative, or the lowest point, is about here. So, I mean, it seems to be working up to that point, but here it says isolation, and then I guess you should push the isolation, and then it's doing something differently. Probably it only works in these three, but no matter what I put on here, nothing seems to make any kind of sense to me, to be honest. So maybe it just don't work at that point. But I want to try capacitors instead and then play a little bit with that. This is 220 nano, and I am in this range is 100 nano. So I think this is just how it is. This is not the full scale, but this is the first number one. This is just something we need to understand. Probably this is explained in the manual. So this is 100. So that will be 200. Aha, see, we're getting close. And then we can seek the lowest point, and it is very close to 210, maybe a little bit more. Something like that, right? So you can also measure capacitors at, well, one of the ranges tested so far, right? But that is a good starting point. Can it also measure using the built-in signal generator? So now it is running at 1 kilohertz, and let's see. Yeah, now it's much more aggressive, and this is of course the much higher frequency. You get much more signal, and this is very useful if you're measuring small capacitors. That is definitely why they have this option to use a much higher frequency. Aha, pretty cool. Just to show the small capacitors also work. This is a 22 picofarad capacitor. And of course, no, it's not that crazy sensitive. And look at that, we can even give it a lot more here to see. I really like the way that this works. It's really accurate and easy to understand. See, this is what, probably 24 or something like that, right? So what if I remove the capacitor and then go to 0? Ooh, it peaks at 0. Maybe that is the idea. You go with a screwdriver here and adjust for 0 when nothing is connected. Haha. So I removed the side panel to get access to this one. Oh, that explains why it's not working. Look at that. Okay, that is not what I expected. How is this? You know, getting this kind of damaged, so somebody has been tampering with this one. So it's probably better to see if I can, how can I fix this? I don't know yet. But probably we can look at this little circuit board a little bit better. It's used, well, it's designed for a connector as well. Maybe they're using this amplifier board for some other projects. See if we can do that carefully. This is really, really old style, huh? I don't want to bend the cables that much because it will cause all sorts of problems. What did I do here? Oops. This was probably... I need to remember this. But I don't have this problem here. That is some weird stuff. What is going on here? There's only one screw here at the side. Well, I better put this here so I will remember this. So that is exactly my idea, to remember what is what. And leave this with all the screws exactly like that. This way it's gonna be easier to figure this out. So here is what I figured out so far about this one. It is intentionally made. See, when we turn this, we can actually see they made this cut somehow. And the idea is that this one is supposed to grab onto the main wheel real tight, so you can't really adjust it. But then, click, you put it right there, and then you can adjust the main knob. But if you want to use the geared one, you got almost one turn to adjust it, and then click, you're free again. Really weird design. Who came up with that idea? Everybody's gonna think it's broken if you ask anybody today. That is the weirdest. The manual is in such a bad shape, I couldn't find any information about this, so it really hurt my eyes to try reading it. And then we have this very dangerous situation with the metal pins here unprotected, and there isn't really anywhere to put the wires in here, and I want to keep them as original as possible. So here is my little sketch. I measured what I needed, and I think I could very easily and super fast design this and 3D print a little thing that I can just stick in here, and then it will be nice and safe. Let's try and see that. I'll try to measure this hole because I can't get my measurement tools all the way in the correct angle. So I estimated the hole diameter a little bit wrong. So I needed to add a tiny little piece of sticky tape here, or sticky paper. And now this little part, of course, fits perfectly fine. And we now have a safe unit right here. So after all this, of course, I reckon I had the idea I got the right connectors. This looks very much like the right connector, but it is not. This one is too big. It cannot go into the hole. And it is a 0 point almost nothing, but it is too big. And then I find another one, and this is also too big. And they look exactly like the right type. And I bet these two actually fits whatever they needs to fit, but they don't fit this one. So this is a special one that is a tiny bit smaller than what else you could find out there. So just be warned about that. Here is the schematic of this wonderful unit. I just wanted to show a little bit about how they designed this thing. And back in 1974, transistors and diodes, that was expensive stuff. So of course they are really trying to be as minimalistic as possible, to use as little of those expensive devices as possible. Look at the oscillator, just one transistor, and of course a very complex transformer for the oscillator and balanced output drive. I think that is fascinating. And the mains transformer, look at the 5 output windings with different voltages. Again, very complicated. Only a single diodes for the 8 plus 10 and 200 volt DC supplies. The plus 200 is used for this isolation tester, and so I would have liked a little bit if we had a little 200 volt warning sign or something like that on the front panel. It's maybe written in the manual, but the manual is in a terrible quality. I can't stand reading the text because of this low quality. So I'm sorry if there's something written important in the manual. I can't read it because my eyes, they're gonna hurt. So the relay I was talking about, that is they're driving that relay with an individual AC winding just for driving the relay. That's also a little bit fascinating. But of course, you can't have any of the other unregulated voltages driving a relay, and that will make everything go up and down and whatnot. And then the 3 transistors, a meter amplifier, some diodes to handle the rectification and over voltage and stuff like that. Pretty neat design after all, and it's still working after all those many years. So I think that is what I wanted to show about this unit. So thank you very much for watching. Hope to see you soon again. Bye.